Everybody up, it's time to learn! Welcome to AP Video 3.6, looking at finding the molecular formula. My objective is to find the molecular formula, given that you have the empirical formula and molar mass. Sometimes you may have to solve for this, but once you have that and molar mass, you can find the real, true molecular formula. Just a reminder, turn off those cell phones, turn off the social media, pause, rewind when needed, and take some notes in the margins. Go, go, go. So, molecular formulas, remember, are the true chemical formulas. And you can find them as long as you know two things: the empirical formula and the molar mass of the true molecular formula. So the empirical formula, usually we take percent composition data, and we can get that into an empirical formula. The molar mass of the real chemical, we can actually find that using a mass spectrometer. And the way we're going to do this is, remember that the empirical formula is some kind of multiple, and then you get the molecular formula. And sometimes they are the same thing. Sometimes the empirical formula must be doubled or tripled or quadrupled, and then it turns back into the molecular formula. So the way we're going to find out how many times to multiply the empirical formula by is we're going to take the molar mass of the real thing and divide it by the empirical formula's mass. And basically, this should always fit into it a whole number of times. If it doesn't fit into there a whole number of times, then you probably have the wrong empirical formula. And then once you find that end value, basically you just multiply the empirical formula by that. So let's take a look at a little practice problem here. It has been experimentally determined and calculated that the empirical formula is ClCH2. Determine the molecular formula if the molar mass of the compound is known to be this. So we're trying to find the actual molecular formula. So how we do this is this. First, you find the mass of the empirical formula. So Cl is 35.45 off the periodic table, and we have one of them. Then we have one carbon, and its mass is 12.01 off the periodic table. And then the mass of these two hydrogens here is 2 times 1.01. So the empirical formula's mass is equal to 49.48 grams per mole. So now we found the mass of the empirical formula, and we're going to plug that in the bottom here. So the empirical formula's mass goes in the bottom. The real chemical formula, its molar mass, is 98.96. And here we get our multiplier. When we do that division, we find out that N here is equal to exactly 2. And oftentimes it's going to be something more like 1.98 or 2.04. Those would be close enough we could round to it. So this is a nice problem where it worked out exactly to 2. So if N is our multiplier of 2, that means you're now going to take the empirical formula of ClCH2, and you're going to double the entire thing, and you must do this. So now you double everything, you end up with Cl2, C2, H4. And that would be how you find the molecular formula. So we have this practice problem here, number 4. I would like you to try to do this one on your own. Just a quick heads up here, this is one of those problems where first you have to find the empirical formula, and then you can go on to find the molecular formula. Okay, so just a heads up on that. So do the problem, enter your answer when you're done, and then check to see the answer when you're done and how to solve for it. Go. Okay, now that you've entered your answer, the actual answer is P4O10. So if you have this for your answer, good job. You can stop here. If you weren't able to get to P4O10, continue watching the rest of the video and find out where you made some mistakes along the way there and learn from them. Alright, so the first job is to find the empirical formula using this percent composition data right here. So let's start off by doing 43.64 grams of phosphorus, because remember we're going to assume we have 100 grams, which means we have this many, 100 grams, which means that percent then is the gram amount in 100 grams. And then therefore we have 56.36 grams of oxygen. So then we want to convert these things into moles. So it's 1 mole of P, and use the molar mass off the periodic table. And phosphorus is 30.974, and that equals 1.409 moles of P. And then oxygen, we convert that. We got 1 mole of O divided by 16.0 grams is what O weighs. And if you do that, you end up with 3.523 moles of O. So we got percents into grams, grams into moles, and now we divide by the smallest mole. And the smallest of those two is the phosphorus. Dividing by the smallest mole, hopefully we'll get us to the smallest whole number ratio. So divide them both by 1.409, because that's the smallest mole number we have here. And for the first one, obviously that comes out to exactly 1 mole of P. And if we divide the other one by 1.409, we end up with 2.5. So we did not get a whole number ratio here. So this is where we're going to go back to the previous worksheet or previous video, and it was at step 4, right here. If you don't get whole numbers at that last step there, you want to multiply to get whole numbers. So when you have halves, like we currently do, you have to double everything. If you end up with thirds for your numbers at this point, you have to multiply by 3. So we're going to multiply by 2. So let me get back to it here. Whoops. Okay, so because this is not a whole number, we're multiplying these both by 2. So we end up with 2 moles of P, and now we have 5 moles of O. So that right there is our empirical formula, P2O5. Okay, so now the next step is to find the molecular formula. And remember, what we want to do is we want to find the molar mass of the real formula, and that's probably given to you. And then we got to find the empirical formula's mass and see how many times it divides into that mass there. Oops. So, the empirical formula P2O5, this guy has a mass of 141.95. The molar mass of the actual compound up here was this right here, 283.88. And I think you can kind of see this already. This is going to give us a multiplier of 2. So that means we're going to take P2O5 now and multiply it by 2. So the real answer here becomes P4O10. Alright, so that pretty much does it. That's how you find molecular formula. Come ready to practice some of these and ask questions if you get stuck.